slope, graphing points and lines. So for us to begin to start graphing points and lines, we need to go over the coordinate plane, which is what we see right here. So really what this is, it's set up. So we have, what we have is, we call our x-axis, which is right here along this line, kind of like a number line. And then we also have a y-axis, which is going up and down. So we have our two axes, and they meet where we call the origin. So our origin is that dot right there, which is when x is equal to 0 and y is equal to 0. So it can be represented like this. Now, so we have this, and then let's also talk about when we are going to the right from the origin, this is going to be positive. Let's just make it really big. But if you go to the left of the origin, this is going to be negative. So that these are like our negative numbers. So we have -1, -2, -3, and so on. So on the right hand side, we have 1, 2, 3, 4, and then and it can just continues. Then for our y-axis, if we go, say, up, we have our positive y's. So it just goes up in increments of 1, it's just positive. Then if we go below, this is going to be right here. That is -1, that's -2, -3, -4. It's kind of a little not as clear right there. But the point is that this is all negative when we go down. So if we go down or to the left, it's negative. Or if we go up and to the right, it's positive for those certain axes. So for the coordinate plane, we're going to give directions to a point going right or left. Notice we do our x-axis first. Then we can either go up or down, which is our y-axis there. And we show it as x and y like that. Then if we have an equation, we can pick values for x and then find the values for y, which we'll see in this second example. So now let's go over the examples. Example 1. So Descartes is in bed watching a fly on his wall. This is a true story, by the way. This is when he has the notion to map out the location of the fly on a coordinating system. It kind of just came to his head. And so we're going to graph the following points of the fly's locations for Descartes. So we have these 4 different points. We have 1 and 4, -2 and -5, then -3 and 2, and 2 and -1. So we need to remember we have x and y. So let's go ahead and start graphing these points. Let's use red. So let's look at 1 and 4. So the first thing we're going to do is we see that this is positive 1. So we're going to start at the origin. We're going to leave it continue as green. So we go over 1 for the x, and then for y we need to go at 4. So we go 1, 2, 3, 4. And we just place a dot right there. So we've done this one. Now let's do -2 and -5. Well, -2 means we're going to the left because it's negative. So we go over 1, 2. Then we need to go -5 for the y. So that means we need to go down. So 1, 2, 3, 4, 5. Which will be right there. So we've done this one. -3 and 2. So we need to go to the left for x. We go 1, 2, 3. But we have positive y this time, so we need to go up twice, or 2 times. So 1, 2. And now we have 2 and -1. So that means we're going to the right for x. So 1, 2, but then we have a negative y value. So we go down 1. And we place a dot right there. And so that is how we would graph the different points on the coordinate plane. Now, let's continue on to another example. Example 2. Graph the line y equals 2x minus 1. So what we're going to do here is we're going to make up values of x that we're just going to pick. We're not going to make them, we're going to pick them. And then we're going to have y, which is equal to 2x minus 1. So we're going to find the values of y in order to graph these points. So let's pick 0 first. So when x is equal to 0, we have y equals 2, put in parentheses 0, minus 1. Well, 2 times 0 is 0, and we just have then negative 1. Then let's pick a value for when x is 1. So we have y equals 2 times 1 minus 1. So 2 minus 1 is equal to 1. Then let's pick another value. Let's say when x is equal to negative 1. Well then, y equals 2 times negative 1 minus 1. 2 times negative 1 is negative 2 minus 1, which is negative 3. What if we have 2x equals 2? Well then y is equal to 2 times 2 minus 1. So we have 4 minus 1. So that is then 3. Or what if we had negative 2? Then we have y equals 2 times negative 2 minus 1, which is then 2 times negative 2 is negative 4 minus 1, so negative 5. Now let's go ahead and graph these points, right? So what we're saying, we have 0 and 1 for x and y. We're saying this is 1 and 1. We're saying this is negative 1 and negative 3. This is 2 and 3. And this is negative 2 and negative 5. Now let's graph these points, and then we will draw the line between them all. So let's start with the first one. Notice that we did put the negative sign. Whoops, I did a mistake because this is definitely negative 1. So this is 0, negative 1. So that means we start at the origin. We don't go to the left or the right because x is 0. So we just go down 1. That's where negative 1 is for y. Then, let's go to the next one. We'll put a check mark to say we did it. 1, 1. Well, it means we need to go to the right, because it's positive, 1 on the x. Then we need to go up 1. I'll draw a dot right there. Next, we have negative 1 and negative 3. That means we need to go to the left 1 on the x-axis, and then we need to go down 3. So 1, 2, 3. We'll place a dot right there. 2, 3 then. Start at the origin. We need to move to the right 2, then up 3. So we'll place a dot right there. Then we have negative 2 and negative 5. So we start at the origin. We need to go to the left 2, and then down 5. So 1, 2, 3, 4, 5. So it's right there. Then we need to draw a line between it all. So we just connect it like this. And the line would continue on in both directions. So what we're saying is that any points right along this line, so say we're right here, this crosses right here, we would say that would make this like a solution to this equation. So if we have y equals 2x minus 1, let's check this out. So we have 1, 2, 3. So when x is 3, what does y equal? Well, 2 times 3 minus 1. So 2 times 3 is 6, minus 1 is 5. So we moved over 3, 1, 2, 3, 4, 5, which that checks out. So any point on this line would be a solution to this equation, because whatever x is, then y would be equal. So the left and the right hand side are equal. So that's kind of why we draw lines, is that saying that anything on this line, that's a solution.